All right, so when two atoms bond together, it has something to do with valence electrons. Either an atom's giving up electrons to another atom and they attract with positive and negative charges, or there's some sort of sharing going on. But either way, it has something to do with electrons wanting to be shared in some way, shape, or form. So with this is where bond polarity comes in. So when there's that change in, when there's that sharing of electrons or exchange of electrons, and these two atoms come together, there's either sharing or unequal sharing, and that falls into three different categories here. So we got the three categories of bonds, which are ionic, covalent, and polar covalent. Now ionic, that one's pretty easy. It's just where one atom takes electrons completely away from another one. There's no sharing of electrons. So that is just typically like your, it's like with sodium and chlorine. You have your sodium and you have your chlorine. And the one electron is completely taken away. So that gives you a positive sodium ion and a negative chlorine ion, and the positive and negative are attracted to each other, and that's your ionic bond. Now a covalent, that's where there's equal sharing. So if you have fluorine and another fluorine, okay, one's not giving up electrons to another one, they're just sharing them 100% equally. So that's a covalent bond. Now somewhere between, we have something called polar covalent. That's where it's sharing, so it's kind of like a covalent bond here, but really it's called an unequal sharing. So that means one atom is actually pulling the electrons a little bit more to itself. So the electrons, the shared electrons, are actually hanging around one atom more than the other one. So types of bonds determined by the differences in electronegativities of the two atoms. All right, now you don't have to memorize the numbers. You just have to know which one's more electronegative than the other based on the periodic table. All right? And yes, only one true covalent bond are diatomic elements, right? Where they're the same element. Because if they're the same element, that means they have the same electronegativity, and one atom's not pulling any more than the other one. So, example for covalent bonds. All right, this is how we do it here. So figure out molecular polarity. Yeah, you have to note the direction of the electron pull on the bond. So you have to determine which atom is more electronegative, and which now become the negative side of the bond, and the other side will be the positive side of the bond. So here we have HCl. All right, so if you look here, chlorine, more electronegative. All right, so chlorine's more electronegative, which means it has a stronger pull of those electrons than hydrogen does. So these electrons in this shared in that shared electron pair in that bond, they get pulled closer to chlorine. And hydrogen's left all alone, doesn't really have the electrons around it all that much. So with all these electrons getting pulled closer to chlorine, it tends to take on a slightly negative charge. Hydrogen, since the electrons aren't around it as much, has a slightly positive charge. Now the way we note that is, for hydrogen, we use this symbol here. Okay, that's a lowercase d, lowercase delta in Greek. Delta positive, and that is a delta negative. Okay. Delta means partial. So that means that hydrogen has a partial positive charge, and chlorine has a partial negative charge. Not completely positive, not completely negative, because that would be ionic. So it's kind of somewhere in between. Now, if we looked at it, here's what it looked like. There's your hydrogen, there's your chlorine, so here's your two electrons. All right, so the electrons will be around hydrogen a little bit, but they'll be around chlorine a lot more. So you see that negative charge here a whole heck of a lot more. So that's where you get your partial negative charge here. because it's around there a lot more. Here you got your partial positive. Okay. So if you looked at two atoms that were equal in electronegativity, so if you looked at two chlorines, okay, these two electrons, they go around 100% the same, 100% on both of them, equal amounts. So you get that perfect amount of electron density on both atoms. Again, here, not as much. You're going to see a lot more around one atom and very little bit on the other atom. So that's where you get your polarity for your polar molecule. Right? So if we look at a couple of these, it's like we said with hydrochloric or HCl, okay, chlorine's more electronegative. So the electrons again pulled this way. And we make the little plus sign there to show that that's a positive end. And we can also label it as partial negative and partial positive. Show that the electrons are pulled more towards chlorine than they are hydrogen. All right. Now between phosphorus and chlorine, well, chlorine's a little more electronegative because it's more farther to the right on the periodic table. So again, that's your negative charge. And phosphorus is a partial positive because phosphorus is getting the electrons pulled away from it. Again, between the two chlorines, there's no pull. So there is no positive end, no negative end. Just say there's no charge or no pull. Right. Now, magnitude of polarity. All right, so the magnitude of polarity, this will be the largest magnitude of polarity, and this will be the smallest. Okay, the largest and the smallest, and then obviously PCl's in the middle there. Okay, that's because there's a larger difference in electronegativity for this one here. Hydrogen's on the far side of the left of the periodic table, chlorine's on the far right. So typically, that's how you figure out the differences in electronegativity. If you don't have the values, what you do is you think the farther apart the two atoms are on the periodic table, the greater the electronegativity difference. Phosphorus and chlorine are really close to each other in the periodic table. So their differences, their electronegativity values are a lot closer to each other. So even though it's slightly polar, there is a difference there. Number-wise, if you looked up the values, number-wise, this is going to be a lot less. Okay, so this is a smaller polarity. Okay, I'll say smallest or none, because chlorine and chlorine, they both have the same electronegativity, so obviously that difference is 0. So whenever you want to figure out the polarity of a bond, you just look at the electronegativities of the two atoms, or if you don't have a list of electronegativities, just look how far apart they are. The one farthest to the right, or the one closest to fluorine, that's going to be the most electronegative. And the farther apart they are from each other in the periodic table, the more polar that bond is. And that's how you figure out polarity of bonds. And next video, we'll do a polarity of molecules. We're going to look at the overall polarity of an entire molecule with multiple bonds in there.